Okay, so this is the first day for section 1.3 on relations, functions, and graphs. And we may not get through all of it, we'll see. Some of this will be review, some of it will be new. Okay. First, the author defines a relation. Okay, a relation is any set of ordered pairs. Any set of ordered pairs is considered a relation. And I'm just going to make up, now the key word on this is this. It is a set. In math, if you don't write the right symbols, you're in trouble. So it's a set, so you need the braces. Okay? I always think when I'm doing those braces, I'm going to do a little face, like that. So I get a little ear in there, make a little head. Okay. Get creative. Okay, so I'm going to give you a set of ordered pairs. The ordered pair is 7, 9, and the ordered pair is 0, negative 1. But you have to have the braces for the set notation. Okay, and then we've talked about this before, the domain. The domain is the set of all x values. The set of all x values. So, another key word, another key word is it's a set. So you got to have the set and the x values. Remember, all the ordered pairs are x and y. So this would be 7, 0 is our domain. Some authors will just write it like that. Remember, some authors would say the domain equals 7, 0. Don't let it scare you off if they use the set notation. The set, everybody look up here for a minute. The set of all x's such that x equals 7 and 0. Okay, that first part there is just telling you it's set notation. It's the set of all x's such that x equals. Okay. What's the other one called? The range. The domain and the range. Okay, so the range is the set of all y values. The set of all y values. Again, it's a set. So on this, in our example, the y values are 9 and negative 1. And you could still use the r, 9, negative 1. The only difference on this would be the range equals the set of all y values such that y equals 9 and negative 1. Just a different way to write it. Okay. Okay, and then probably the most important definition, and we've talked about it, algebra all the way through, is a function. A function is a relation. It's actually a special relation. A function is a relation such that, okay, and then the higher you go in math, the more symbols they're going to use. The words such that, you probably won't see that in upper level math. It's going to be written this way. It's a backwards epsilon. Looks like this. A backwards epsilon means such that. Okay? A function is a relation such that for each, and for each, they would probably in upper level math, they won't use that. For each, for all, for every. It's an upside down A. For each, for all, for every. Upside down, capital A. Okay? A relation such that for each x value, it is assigned or mapped to 1 and only one y value. You know, and you may have learned it differently in Algebra 1. I just say for every x value, it can be mapped to one and only one y value. What's the special test that we use graphically to tell what, huh? Yeah, the vertical line test. If it intersects the graph, if a vertical line intersects the graph in more than one point, then it's not a function. Remember that? Okay, so just a reminder, the vertical line test. Some of this you probably remember, but it's good to refresh the memory. If the vertical line intersects the graph in more than one point, then it is not a function. It's not a function. And it's not a function. Okay. Examples. Think back on the 6 trig functions. Okay, and think if I asked you to graph right now, could you graph the sine graph? Where's the sine graph start? Starts like at the origin, right? And remember, we went every half pi. So at pi over 2, it'd be to here, here for pi. It comes like this. Okay. This would be the graph for y equals the sine of x. Is that graph a function? Yeah, it would pass the vertical line test. If you go back to your algebra 2, if I graph like a parabola that opens up, yeah, that's a function. This one's a function. But as soon as I take a parabola and put it on its side like this, it is not going to pass the vertical line test because it's going to intersect in more than one point. So this one would be no, it's not a function. Okay. All 6 trig graphs, sine, cosine, tangent, okay, cosecant, secant, cotangent, they are all 6 trig functions. Okay. Those are functions. What are some of the conic sections? Let's say I give you a line like this. That is a line is a conic section. Is that a function? Yeah. What's the only type of line that's not a function? Vertical. Okay. What's another conic section? Like when you slice a cone in different ways. An ellipse. You know, if you take a cone shape and slice it this way, slice it with a plane, you're going to get an ellipse. Is that a function? No, that's not a function. This one would be yes, it is a function. Another conic section would be like a circle. Okay? A circle is not a function. It would intersect in more than one point. We talked about the parabolas already. What's the last conic section for hyperbolas? Okay? Hyperbolas, yes or no? Depends on how I draw it. Okay, if I drew a conic section like this, hyperbola, is that a function? Yes. Okay, that one is a function. But if I do this, okay, and this would be where you take 2 cones, one right above the other one, and slice it straight down with a plane. You're going to end up with a hyperbola that looks like this. Then is it a function? No. So this one would be no, because you'd intersect it in more than one point. Okay. So anyway, you should be able to tell graphically. Plus, you should also know in upper level math what the conic sections are from your algebra 2. Okay. Okay. Now I'm going to go through a couple of examples. And say they ask you to, here's the directions, identify the domain and range. Okay? And here's the graph. When you do the domain, you always go left to right across the screen. Okay? And you're looking for domain. What's the first x value that I get to? 0. And it's a solid point. So x is 0. And what other x values are used? As I go left to right, what other x values are there? Huh? All of them. Everything greater than or equal to 0. Now, here's the deal. What you're used to using in Algebra 2 and Trig and Pre-Calc, you would have said x is greater than or equal to 0. Okay, then you go to the back of our Calc book. It doesn't look anything like that in the back, so it's like, I don't know if I have the right answer or not. So you got to get used to this author. Okay, so from what we did the other day, 0 is included because it's a solid dot. Is that a parentheses or a bracket? It's bracket. So for our domain, it's going to be 0. And then everything greater than 0, okay, because we're using all these x values. If we extended that up, we'd still be using all the x values. So it goes to positive infinity. Every time you write the infinity symbol, you use a parentheses. Okay? Okay? You use a parentheses. Okay? She's not enough. You got to stand up, walk around a minute. Okay. Really? Yep. I'm serious. Okay. We're losing one. Okay. Okay, same idea now. For the range, you go from the bottom up. First y value you use? 0. Okay, and above. So you would have said, back in Algebra 2, you would have said y is greater than or equal to 0. But now it's going to be still 0 to positive infinity. And infinity is always a parentheses. Why is that not a bracket? Bracket means it's closed in. Can you tell me where the end of infinity is? No. So that's why you use a parentheses. So just common sense on that. Okay. Next example. Okay. Say I give you a graph. Draw that a little bit bigger. Say I give you a graph, and I want you to go up to 2 and do a asymptote, horizontal asymptote at y equals 2. Go to the left 1 and do a vertical asymptote at x equals -1. Okay? Now put the graph in here and here. Okay, now what we would have done before for the domain, tell me in that picture what's the only x value that we're leaving out. What x value are we leaving out? -1. So we would have said, for the domain, we would have had to probably write it out in words. All reals, remember we used the double bar R, all reals except x cannot equal -1. For the, well, let's do the domain the other way. Okay, now here's how it would look in the back of your book. Okay, this indicates that it's going out to the left to which infinity? Negative infinity. So we actually start at negative infinity to -1. Did we include -1? No. So if we were doing this, we'd go negative infinity to -1. We did not include -1. And now if there's two parts of the graph, everybody look up here, you do a union symbol. It is not this. There is no tail on it. It's just union like that. Okay? Union, because now we're going to do the second part of the graph. Okay, so -1 is not included. And now we go from -1 to positive infinity. So -1 is not included to positive infinity. If you ever have two parts of your graph, you're going to have two of these. If there would, say I put another vertical asymptote over here, then there would be another union symbol and a third part over here. Okay? Okay, now let's do the range. Okay, so if we do the range, start from the bottom up, what y value are we leaving out? 2, right? So you'd say we're going from negative infinity down at the bottom to -2. It can't be -2 because that's an asymptote, so that's a parentheses. And now union that, then we're going to go from -2 up, -2 still not included, up to positive infinity. Okay? What's that? What? Oh, sorry, that's my fault. You guys got to say something quicker. +2, sorry, it's +2. You don't really have to write positive on there. You could just leave it out from 2. Sorry, that's my fault. Okay, any questions on how to write those? Listen up a minute. I won't count it wrong if you write it this way, the old way, okay, for a while. But I will tell you, you have to adjust. As we go through this book, you got to adjust. Okay, so try to start switching over. Okay, you got to get used to the new author. Okay, then a little bit of this we've already had before. We talked about even functions last year. Anybody remember what an even function is? Anybody remember what it's symmetric with respect to? The y-axis. Yep, even functions are symmetric. The WRT means with respect to the y-axis. An example, like if you had a parabola that opened up, like even if I said the parabola was y equals x squared. Remember, if it's a y to the first and an x squared, it's going to be a parabola. If the a in front of that x squared is positive, it opens up. If it's negative, it opens down. So, and on this one, let's say I look at 2 and -2. If the x values are opposites, the y values are the same. It'd both be 4. Okay? And it looks like this. F of -x equals f of x. The x values, if you look at this, the x values are opposites. That's like the 2 and the -2. But the y values have the same sign in front of them. That's like the 4. Okay? Between sine and cosine, which one's even? Cosine. Okay, because you could take the cosine graph and fold it over the y-axis and get the same graph. So an example of another one that's even is y equals cosine of x. Because remember that graph starts up here, like that. So you could fold it over. Okay. Another example of one that's even graph might be a graph that looks like this. That's like a cissoid graph. Okay. We also did odd functions. Okay, odd functions are symmetric with respect to what? The origin. Good memory. Symmetric with respect to the origin. Okay. An example of that would be like the sine graph. Remember, the sine graph started at the origin at pi over 2. We went up to 1. Okay. Pi, we were back down to 0. But if you took this graph and rotated it Okay, that means you can rotate it 180 degrees. Whoops. Rotate it 180 degrees about the origin and get the same graph. Okay. And that means if the x values are opposites, like this one's pi over 2 and negative pi over 2, and the y values are opposites. So that's going to be like f of negative x equals the opposite of f of x. So here the x values are opposites, the y values are also opposites. Okay? They're also opposites of each other. Okay? Another example of that is a cubic graph. Like y equals x cubed is going to look like this. Okay, if you put a point at the origin and rotate it 180 degrees, you're going to get the same graph. Okay. Okay, the last one we're going to look at for today is another, what they call in the book, they call them a library function. That means a library function means it's built in on your calculator, and that's the absolute value. Okay, the absolute value function. Okay, it is a library function. That just means it's built in on your calculator. Okay, it'll look like this on paper, y equals the absolute value of x. But on your calculator, it's going to look like this, y equals the absolute value of x. Okay, so on your calculator, go to your y equals, make sure you're in function mode. Okay, and get to y sub 1. And then the absolute value function, remember, is under the math key. Okay, so go to your math key. Math key, and then right arrow over to number. Okay, and it's number 1. Absolute value, and then put in your x in the parentheses. And then just do zoom 6. Zoom 6. And normally it looks a little bit better symmetric, so do zoom 5 to square it up. Okay, so it should look like this on your calculator. I did zoom 6 and then I did zoom 5. Okay. Now, what I just did, if a year from now you go back and you look at your notes, do you know where the absolute value function is on your calculator? Okay. If not, you do this. You say it's under the math key, and I usually circle it, and then I right arrow over to number. And then it was number 1, right? Something just to remind you, because I won't be there a year from now to tell you where it is. Okay? Okay, that's as much as we're going to do on notes today. Okay, we'll do some more tomorrow.